herself, so I'm gonna let her do all the talking.
So here's a little algebra review. Ms. Stewart?
Mr. Haas, I'm excited.
All right. Just says factor and simplify. And, you know, this is a very specific type of problem here.
Yes, it is.
This is really, the reason we're doing this is the kind of thing you're going to end up with after you take the derivative of a more complicated function. You're going to learn something called the chain rule, and you're going to end up with things that look like this. So then you're going to have to simplify them.
Right. And simplify in this context doesn't mean what it often means, which means multiply everything out. And simplify in this context means really make it look simpler. Let's factor it and just make it one term.
And we will try to guide you. I mean, here it says factor and simplify. If we wanted you to multiply everything out, that would be, you'd say distribute or multiply and simplify.
Right.
So I'm just going to look for the largest common factor, greatest common factor. Nothing new from your factoring days. And I can see that both terms, and I think that sometimes students have trouble recognizing the terms here. I have two big terms.
Two big blobs.
Two big blobs. The first blob, I see that I have this little piece and this little piece. It looks like I can factor out a 2x from both of those. So I will factor out a 2x. And it looks like I can also factor out one of these big guys right here. This whole big glob, a 3x plus 5 squared.
Very nice.
You see what's going on?
I see what's going on.
And then I usually just put square brackets just so that I can kind of see the difference. There's nothing special about a square bracket, really, in this case. So what times 2x gives me the 4x squared? I think that is going to be a 2x.
I would concur.
And I factored out two of these guys, so that's gone. Inside I have a negative 3, right? Because 2x times negative 3 gives me negative 6x. And I have one of these guys, 3x plus 5.
So you just factored out a greatest common factor.
Exactly. I mean, I pulled out two of these guys for both of these.
Yeah, beautiful.
Hopefully that's working out for you, Ms. Stewart. And then I'm just going to kind of clean up what I have left there. I have a 2x, a 3x plus 5 squared. And inside here, I have a 2x, and I have to distribute this negative 3.
Right.
The sign goes with the 3 there, so negative 3. Gives me a negative 9x, negative 15. I can do a little bit more combining. 2x, 3x plus 5 squared. And I have a 2x minus 9x, negative 7x, and negative 15. Really, that's as simple as I can make it. I mean, I suppose I could bring out the negative from both of these and write it out front. Sometimes you would see that, but it kind of looks a little funny sitting there.
Right.
But there's really nothing more that I can do. That is fully factored and simplified.
And now you have one term. It's one big blob.
One big blob.
Very nicely done.
Thanks.
Here we have another expression that we want to simplify. Now this is, as you might notice, Mr. Haas, a rational expression. Meaning we have a fraction. And if you recall, whenever you're asked to simplify these things, we always factor first to see if we can then divide. Well, I should never say always, but we often like to factor first to help us divide things out, because the dividing is going to help us simplify. So let's look at that numerator. I have two big terms, right? Here's my first term, here's my second term. If I want to factor that, we're going to look for a greatest common factor, a GCF. Mr. House, what do those both have in common, would you say, those two terms?
I would say they both have a 7x plus 1 cubed.
Yes, they do. They both have a 7x1 cubed. So I'm factoring that out. I'm pulling that out. I'm going to do the big brackets that you used as well. What I have left in this first term, after I divide out the 7x plus 1 cubed, is just this 5x times the 7x plus 1. Okay, plus... What do I have left here if I divide out a 7x plus 1?
1.
A 1.
Yes, students forget that 1.
Do I have to put that 1?
Oh, you do. Absolutely. Yes.
Right. That's like a place saver. You always have to think, if I were to multiply things back, you need to end up with what you started. So 7x plus 1 to the third times 1 gives me that.
Right.
All right. So here I have my denominator, which is just hanging out for now. Hey, do you see what I see?
I think I do.
Yeah. So I technically just have one term up here. I certainly want to clean that up. but I have a blob of things multiplied. If this is multiplied by that, then that's free to divide with this. I have 3 on the top, I have 6 on the bottom. That leaves me with 3 in the denominator.
Like it.
5 seconds?
Yeah, almost there.
All right, let's zip up here. Now all that's left to do is to clean my numerator up a little bit. I have 5x. Oh wait, I don't have 5x. I'm distributing that 5x.
Yeah.
So I have 35x squared. Let's just erase that whole thing. 35x squared plus 5x plus 1 all over 7x plus 1, quantity to the third. Now, whenever you're in this situation, you always want to look and say, all right, could I simplify this more? If that's factorable, would that lead me to be able to do any more dividing? A, I don't think that's factorable.
Yeah,
B, even if it were, this would not be a factor, so I'm not even going to bother to pursue that. I have simplified
You are done.
that
Yeah,
expression.
it's not too bad.
Yeah,
All right. Thanks, Miss Stewart.
anytime.
In the not too distant future, you are going to find the derivative of implicit functions,
Fun.
which you're not sure what they are yet, even, I'm guessing. But anyway, you're going to use something called implicit differentiation. And you are going to end up with a mess that looks like this. You got a whole bunch of x's and y's and numbers in there. And then you have this thing, dy dx. Look at all these dy dx's. You know what dy dx is, by the way, Ms. Stewart?
Yeah, it's Leibniz's
It's just notation, right.
for the derivative.
So all this means is 2 times x times y times the derivative of y with respect to x. Derivative of y. Just, so the derivative of the function. I really could write y prime here, I suppose. But, if I start writing y prime, why do you think that's a bad idea?
It's going to look like a y.
Yeah, I mean, if I have 2xy and another y there, you're going to, it's going to get it mixed up.
Yeah.
It's going to look like y to the first power.
Right.
It's not. This is the derivative. Right? So, what I'm trying to do now is solve for the derivative. I just want to get it all by itself.
So basically, we're treating dy dx just as a variable
It's like saying x.
that I want to isolate, that I want to get by itself.
Exactly right. So I'm just kind of going through and sort of marking all the terms that I have.
Very nice.
I've got 2 terms on this side and 3 terms on this side. I want to solve for dy dx. I'm just going to move everybody with the dy dx to one side.
Yeah.
That's all I'm going to do.
Because you're wanting to get dy dx by itself.
That's right. Did I say that part already?
We're solving for
Okay.
dy dx.
So here's 2xy dy dx minus 3 dy dx. I'm going to move this dy dx guy to this side.
Very nice.
So I will subtract 2y dy dx. Here it is. I've subtracted it over. I hope I can just kind of do that in one shot.
Yes.
Is that all right if I don't write minus 2y
Yes.
dx on both sides?
Absolutely.
Boom. There it is. Here's my equal sign. I have an x squared and a plus 1.
Left on the right.
Everybody with the dy dx went to this side, everybody else on the other side. If I had a non-dy dx term on this side, I would have moved it over.
Moved
to the
it
other
over
side.
there. Very nice.
So now what?
Well, we're solving for dy dx. I want to, gosh, I don't think I can combine those terms because they're not like terms, so we only have one thing to do.
Factor. Just like the other
Factor.
problem, right? I'm factoring something out. I'm factoring out the dy dx. And I just write down what's left. 2xy minus 3 minus 2y. Oops. I'll keep my square bracket. I don't know why. I just felt like writing a square bracket.
Why not?
Just do it. I don't know.
Yeah, so there you're able to get dy dx out by factoring it.
Factor it
And I
out.
think I know what you're going to do next.
I'm just going to divide both sides by this big mess right here. 2xy minus 3 minus 2y. Divide this whole side by 2xy minus 3 minus 2y. And I think I'm done.
You're done. That all equals 1.
Just 1. And I guess I could rewrite the answer. Shall I do that?
Sure, why not?
You got me still?
I will.
So I have dy
momentarily.
dx equals, this whole business is just x squared plus 1 over 2xy minus 3. And I know this looks like a mess, but in fact, I have solved for dy dx. And that is my answer. And again, the only thing that you might want to do is make sure that there's nothing that I can factor out from the top. and the bottom that I could simplify further. But here, certainly the top is unfactorable. There's really nothing that I
I
can
had a
factor out
problem
too
in the
long.
early hours, so
Go
stopped
ahead,
it
no,
dead
you're
for
done.
real
You're solved.
too.
Beautiful. Thank you.
But I cut some cord and I shouldn't have done it, and it won't forgive me after all these years. So send it to a place in the middle.